Okay, Shania, is this the problem?
Yes.
All right, so 39. 38 looks similar, so I'll do 38. And you can do 39 later, okay?
Yes. Wait, I think 40 is a better one.
40, all right, let's do
Yeah.
40 then. 40, the question is to rationalize each denominator. Rationalize. So the key word here is to basically remove or get rid of the radical from the denominator. That's what rationalize means. So rationalize each denominator. So we want to transform this in a way that we end up with a new expression or a number without the radical on the denominator. It doesn't matter if the radical is still here, up in the numerator, but it can't be here. That's what we mean by rationalizing the denominator. Okay, I'm going to open the whiteboard and explain this further. I want everyone's attention. Please watch for the whiteboard. Let me just open up my whiteboard here. All right, so the unit was 8.5. And the question we're doing is number 40. So rationalize. I want to rationalize this fraction. So radical 7 over radical 6. Okay, again, it's important to understand the question, especially if it has a keyword. The keyword here is to rationalize. Again, it means getting rid of the radical from the denominator. So to do so, you basically, to get rid of a radical from a number, you just times that radical by itself. You times that radical by itself, the radical goes away. So what you want to do is, for example, radical 6. So to get rid of the radical from 6, we got to times it by itself, by radical 6. Okay, you end up with radical 36, which is, what's radical 36, or the square root of 36?
6.
9 and 4.
6. 6.
It's just 6. It has a perfect root or radical. Okay, so to get rid of any square root, just times it by itself and it goes away. So that's what we're going to do here. We're going to take this fraction, write it again. So to get rid of the radical 6 again, we're going to times it by itself, like this. And so that will get rid of the radical. It will be just 6. But this is a fraction. If we times the bottom by radical 6, we got to times the top by, what do you multiply?
Radical 6.
Radical 6, that's right. To keep the ratio the same, to keep the division the same, we get an equivalent fraction. So this fraction is the same as this, same ratio. So make sure you multiply both by the same thing, so we can get what we call equivalent fraction. So these two are equivalent. Okay, we call them equivalent fractions. The rest is just to simplify the radicals here. So we end up with, what's radical 7 times radical 6?
Radical 42.
That's right. They both have the radical with the same index, radical index to, we can multiply the radicands. The radicands meaning the numbers inside the radical 7 and 6. Over, as we did earlier here, we times these two into 36. Then you get radical 42. Can we simplify radical 42? So this turns into basically just 6. And you attempt to simplify the other radical. We don't know, I mean, it's not a perfect radical, it's a decimal. But try to break this down into two numbers that multiply to 42. Maybe one of those numbers has a perfect radical. So to do so, 42, let's break it down into a multiplication of two numbers. Give me all the combinations of numbers that multiply to 42. So one of them is 6 and 7. Okay, what else? What other numbers might multiply to 42?
2 and 21.
That's right, 2 and 21. What else? 14 and
3.
And 3. 42 itself and 1, which won't be very helpful. Anything else? Any other numbers that multiply to 42? It's probably about it, right? So does any of these numbers have a perfect radical?
No.
No, that's right. There's 6 and 7, no radical. This and this, no radical. So that could be simplified. So we'll leave it like this. If this 42, for example, was 48, it would have been a different scenario. We could do, for example, 16 times 3, right? We can say radical 48, and we can turn that into 16 times 3. Then we can split this into two radicals, radical 16 times radical 3. And what is the radical of 16? What's the radical? The root of 16 would be?
4.
4, that's right, 4 radical 3. So if we had radical 48, we can simplify it into this. So we break it down. If it's not a perfect radical, or it doesn't have a perfect root, you can turn it into two numbers, 16 and 3, for example. But in this case, with 42, none of these have a perfect radical. So that's basically your answer. And we just rationalized it. That means we removed the radical from the denominator. Okay? If it's just one radical times it by itself. If it's something like this, if you have this in the denominator, for example, that, then you got to times it by, what do you times it by to get rid of the radical? If you have this in the denominator, for example, if you had something like this, you got to times this by itself.
Conjugate.
Conjugate, that's right. Change in this sign here. Also the same at the top. Okay, if it's by itself, just times it by itself. If it has an addition or a subtraction, you want to multiply it by itself. Make sure you switch the sign to the opposite. That way you can have the middle terms cancel out. Then you distribute this, and your radical will disappear from the denominator. Okay, let's actually finish that example. So we can do radical 3, right? Times 1 is radical 1. Then you can do radical 3 times radical 3, which is radical 9. Then radical 1 times radical 3, which is 1 radical 3. And then negative 1 times radical 3, which is negative 1 radical 3, right? Finally, what's the last multiplication?
-1.
That's right, -1. So we distribute. Now, what do we do further here to simplify this? Can we add these two?
No.
These don't add up, they're different, so we're just going to write them down. Radical 3 plus 1. And what happens to the denominator here? First of all, what is radical 9? That's
3.
That's right. What else? What else happens in this denominator?
Cancel out.
Say it again. What happens here now? So 9 is radical 3, and what else?
And then you cancel out one
Minus
radical 3.
That's right. So we're going to cancel these middle terms. They're opposites. That's the reason why we switch the sign in the middle, so we could have these two cancel out. If you don't switch the sign here, these will not cancel out. They will add up. Okay, so those go away. Minus 1. So radical 3 plus 1 is 2. Did we rationalize our fraction here?
Yes.
Yes. Again, the purpose of rationalizing is getting rid of the radical. As you can see, we have 2 here. As long as you don't have a radical in the denominator, it's fine to end up with a radical here. That's okay. But rationalizing means getting rid of the radical from the denominator. And it's very useful. You'll see later, in later examples that it's very useful when we multiply, add, subtract, do a bunch of things with the radicals. Okay, so this example was again question 40 from unit 8.1, and you're doing question 39 similarly, and this is just another example. So the expression here was, you can think of it this way, so the expression or the example was rationalize this. Okay, so that's an example that I made up. Okay, rationalize this fraction. We times the bottom by the conjugate, which is a radical 3 plus 1. And whenever you multiply a fraction by something, the bottom of the fraction by something, you gotta multiply the top by the exact same thing. That way you get equivalent fractions. So this fraction and this are the same. Just like when you say, for example, 2 over 3 is the same as, let's say, you can multiply these by the same thing, for example, by 5 and by 5. Okay, it's the same fraction. These are equivalent because we times both top and bottom by the same thing. So that's 10 over 15. So if you divide these in the calculator, I believe this is 0.66. This will be exactly the same as that. The numbers are different, but the ratios are the same. Okay, the division are the same. Okay, does that make sense to everyone?
Yes.
Yes.
Okay, everybody else, let me hear from you, please. Saleha, Ruby, Paras, Gangang,
Yes.
Alba, Shania, and Fiona. Again.
Yes, it makes sense.
All right. Very good. So that's how you rationalize fractions. All right. Let's take another.
Wait, at the bottom, where did you get times 5 from?
This is just an example. Okay.
Oh, okay.
Just example. It's random. It's just showing you that when you have a fraction, you can multiply any fraction by the same numbers up and down, and you get an equivalent fraction. So this and this are equivalent. Okay, they're equivalent as we said earlier. All right. Any other questions, everybody?
Hello, teacher.
Yes.
I have a problem is 8.5, number 68.
Okay. So we're still in the 8.5. Let me scroll down to 68. Okay, so that's that's quite similar to this. So 68 is kind of like this. Let me write it down. So instead of doing 68, I'll do probably 70. So 70 is similar. Let me do 70. So question 70, same thing, rationalize. And that's -3 over radical 2 plus radical 5. Okay, so to get rid of the radicals here from the denominator, what do we times by? We're going to times
Radical.
by
Radical 2.
the conjugate of this, which is the same with a minus. Let me see, it's one of them is radical 5. Yeah, the second one is radical 5. All right, so here, I guess I'm going to times this by radical 2 minus radical 5. Same thing up here, radical 2 minus radical 5. Please rejoin right away. We're going to get disconnected in a few seconds. Let me save this. Then we just distribute, okay? Make sure you multiply by the same thing. So -3 times radical 2 would be -3 radical 2 minus -3 times radical 5. So that's +3 radical 5. Okay, here, radical 2 times radical, that's radical 4. Then radical 2 times -10, which is -5, which is radical -10. And again, radical -10 or +10, radical +10. Finally, radical 5 times negative radical 5, that's negative radical 25. Then simplify. Can we add these two at the top? We can't add them because the radicals are different. Here, these two cancel out, so we have 4 minus 5 left. This is -1. Okay, so -3 radical 2 plus 3 radical 5 over 1. No need to write the 1. Actually, over -1. So we got to write that -1 here. You could move the negative up, okay? Turn this into a plus and this into a minus if you move the negative up. The final answer would be 3 radical 2 minus 3 radical 5. And as you can see, no longer have the denominator, and we just rationalized this. Okay, this